Okay, everybody, this is a guided walkthrough for the Bandit 11 level from the Overthewire.org game, and let's go ahead and start. All right, everybody, so the first thing we need to do is we need to log into the level. So to log into the level, we're going to be using this command over here, SSH bandit11 at bandit.labs.overthewire.org -p2220. So we give this command, and then it's going to say, are we sure you want to continue connecting? The answer is always yes. Hit enter, and then you're going to need to supply the password. So the password, we're going to paste it in, and then we're going to hit enter. And we're now logged in. All right, so what are we doing in this level? So in this level, in this directory, we've got a data.txt file. So we're going to find out what exactly we need to do to finish this level over at the Overthewire goals page. So we're going from level 11 to level 12. Okay, and in Bandit level 11 to level 12, the level goal here says the password for the next level is stored in the data.txt file, where all of the lowercase a to z and uppercase a to z letters have been rotated by 13 positions. So they're talking about letters being rotated by 13 positions, and let's see what it actually looks like. So if we go back to our terminal, we're going to take a look at the data over here, and it looks like we've got some sort of encryption or encoding that's happening in this string. And the type of encoding or encryption that we're talking about, let's go ahead and talk about what kind of transformation has been done over here. So in Bandit level 11, we're talking about the ROT13 cipher. So the data.txt file contents are an encrypted message, and the encryption method is called ROT13. They actually tell us that in the description over here. So lowercase and uppercase letters have been rotated by 13 positions. So the ROT13 cipher is a simple substitution cipher where the encryption method is to shift each plaintext letter by 13 positions in the alphabet to form the ciphertext. So if we have this little chart over here, it's quite easy to understand what transformations are being done. So for example, if you want to encrypt a message using ROT13 and you've got the letter A becomes the letter N. And if you have the letter N, that would become the letter A. And if you have the letter M, it would become the letter Z, and the letter Z would become the letter M, and so on and so forth over here. So what we can do, okay, so let's do a little more explanation. So if we use this cipher to encrypt the plain text HackerFrogs, the resulting ciphertext would be this over here. So we use the we can use this chart over here to perform the operations, or we can just shift each one of these letters by 13 positions to get the ciphertext. So this is called plain text, and then after the cipher has been applied, this is called the ciphertext. So to decrypt the ciphertext, we would do the exact same operation, shifting each ciphertext letter by 13 places in the alphabet. So to solve this level, we're going to be using the Linux tr command. There are a few different ways we can solve this, but since we're working inside of Linux, we'll try to keep on working inside of Linux. And the Linux tr command can be used to transform specified characters into other specified characters, and it can be used to simulate the ROT13 decryption. So this is the command we're going to be using over here. Let me go ahead and get that from my GitHub over here, and I'll just copy this. And we're going to paste it into here. Okay, so what exactly is this command doing? So first of all, we read the data.txt file, and then we supply a pipe. So remember that the pipe is going to provide whatever is the output of the first command, and it's going to provide it as the input for the second command. So we're using the tr command, and we're specifying that all capital letters A to Z and all lowercase letters A to Z are going to be mapped to capital N to capital Z, and then capital A to capital M, and then lowercase n to lowercase z is going to be mapped to uppercase A to uppercase M. Okay, so let's go ahead and run this command over here. So if we run the command, then all of the letters are shifted by 13 positions, and we get this message here. The password is this. So let's go ahead and copy this. That's yeah, okay. One thing that we have to remember is that numbers are not affected. So if there are any numbers inside the ROT13 message, the numbers are going to remain exactly the same. But anyways. Okay, so we got the password by using the tr command over here. So if for some reason we suspect something is ROT13 encoded, we can actually copy it, and then we can use a bunch of different web solutions. So we can go over to Google, we can look for something like ROT13, and then we can go to this website, for example, and we can just paste in whatever we want in here, and it's going to do the ROT13 encryption or decryption. Remember, because ROT13 is a symmetrical cipher, the encryption and decryption operations are exactly the same, but we can actually get the password for this level by using a web app as well. All right, so before we finish, let's do a little recap over at GitHub over here. So what did we do? So the username is Bandit11, the password is this, and the method of solve here is use the tr command to emulate ROT13 decryption, and we've got our command over here. All right, everybody, that was a guided walkthrough for the Bandit 11 level from the Bandit CTF game over at overthewire.org. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.